Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something. Now, welcome back to our machine learning class. Let's continue of our learning about recommendation algorithms. In this part, we'll show you how the algorithm works, and we will provide you with an example to help you better understand how the algorithm work. Before we begin today's lesson, let's first review some important concepts in machine learning. The first metric is E.
RMS is a commonly used evaluation metric in machine learning.
It measures the average square difference between the predict value and the actual values. It is particularly useful for a regression problem, where you are trying to predict a continuous numeric value. The lower RMSE value indicates the better predictive performance. CTR is a metric often used in competition advertising to measure the effectiveness of ads. It's the ratio of users who clicked an ad to the total number of users who viewed the ad. A higher CTR indicates that the ad is more engaging and relevant to users. You see of the ROC curve in the context of the recommendation system turned into a machine learning problems. The errors under the ROC curve is a metric used to evaluate the performance of binary classifiers. It's often used to assess how well a model can distinguish between positive and negative instances. A higher AEC indicates better model performance. F-score is a measure that combines both precision and recall. It's particularly useful when you want to find the balance between these two metrics.
A score becomes important in situations
where there's an uneven class distribution, or when false positive and false negative have different costs. Prediction accuracies refers to the level of agreement between the recommended items generated by the offline algorithm and the actual user behavior. It's a measure of how well the algorithm recommendation match what user actually do. Precision and recall are metrics often used in search technique and information retrieval. Precision measures the ratios of relevant items among the items recommended.
The turnover of relevant items related to the total number of relevant items.
These metrics are crucial for evaluating the effectiveness of algorithms in retrieving relevant information. These metrics take key roles in assisting the performance of machine learning model and recondition system in various contexts. Accuracy and recall are two widely used metrics in the field of information retrieval and statistical classification.
For evaluating results quality accuracy
is the ratio of the correctly classified instance to the total number of instances. It measures the precision of the retrieval system. In other words,
it quantities how many of the retrieved entities,
such as documents or web pages, are correct. It's a vulnerable measure of system abilities to accurately identify relevant items. Recall, also known as the sensitivities or true positive rate. It is the ratio of the number of relevant instances that has been retrieved to the total number of relevant instances represented in the datasets. It measures the comprehensiveness of retrieval systems. Recall qualifies
how many of all the relevant interviews
have been successfully retrieved by the system. In information retrieval, these metrics address different aspects of system performance. Accuracies focus on the correctness of the retrieved results, while the recall emphasizes the system's abilities to find the all relevant items. Both metrics are essential for assessing the effectiveness of search algorithms, recommendation systems, and classifiers. They help strike
between the positions and completeness
in various applications. Let's look at how the recommendation algorithm implemented in Python.